All right, let's handle part B. We're going to have the region revolved around the y-axis. Okay, so we're going to use both disk and the shell method. Here we go. To be able to use the shell method, I'm going to get a slice parallel to the y-axis. Okay, so that after the revolution, I'm going to have a shape like this, right? And this comes with thickness dx. Okay, so you're talking about a shell coming with thickness dx. Okay, and in the second part, we're going to use the washer method. That means I'm going to take a slice vertical to the axis of revolution from the region. Okay, so here we go. This is my representative slice, and if I revolve this around, I'm going to get a washer. Okay, and this comes with thickness dy. And I'm going to find the volume of the representative washer and written in terms of y. So this is y equals x squared and y equals radical x. Okay, let me just write those down here. So this is y equals radical x, and this is y equals x squared. Okay. So let's start with the shell method. Okay. So let me just clean this. All I need is the radius of the bottom of the slice, which is this part. So p of x, and I need the height of the slice. Okay, h of x, and that already comes with thickness dx. Okay. So one observation here is that the bottom portion of the slice touches the purple curve, and the upper side of that touches the blue curve. Okay. And all I need is the x representations of these curves, which is exactly what I have already. Okay, so this is y equals radical x. This is y equals x squared. Okay, let's start. So I'm going to assume that this p of x is just equal to x because that's the starting point. So let's say like this slice is x units far from to the axis of revolution. Okay. So I need the y coordinates of red marked points, so that let's see, because the difference between the y coordinates of these points is going to be exactly what h of x is. So I need this distance as well as this distance. Okay. Well, here, the little distance here, okay, the little distance here, which is the one corresponding to the red mark at the bottom of the slice, is determined by the purple curve. So since x coordinate of that is x, the y coordinate of that point is going to be x squared. So there you go. This part is only x squared. And the other red mark at the top is going to determine the higher part, right? So this distance here, okay? So that is radical x, okay? So this way I can write h of x as the difference of radical x minus radical x and x squared, okay? So this is the difference of radical x minus radical x and x squared, okay? Here we go. So right now I can write down the volume of the representative shell. So here we go. Volume of the representative shell is equal to 2 pi times the radius, which is x, times the height, radical x minus x squared times dx. Okay. And in this green region, x's are ranging in between 0 and 1. Okay. So that the volume integral is going to be 2 pi integral from 0 to 1 x radical x minus x squared times dx. And we are told not to evaluate the integral here, so we're just going to leave it as this. And if you want, by the way, you can just go ahead and find the volume. This is sort of like the volume, right? And in this particular case, we use the shell method, right? Shell. All right. I think we're done with this part, and let's go ahead and use the washer method to write down the same volume, but with a different formulation. So this time we're going to write everything in terms of y, okay? So I need the inner radius and the outer radius. Here we go. So the inner radius is this part. Okay, let me call it little r. And the outer radius is this part, that's capital R for the representative slice, right? All right. So this time we're going to just say that this slice is y units far from the x-axis, okay? So for that reason, let's say this is just y, okay? So now look at the x coordinates of the red marks, okay? Because that's the x coordinates of those red marked points are going to determine the little r and capital R, okay? But for me to find those, I need the x equals y type representation of these curves. Let me just write those here. So here x equals y squared, and here x equals radical y, okay? Both red marked points come with the coordinates with the y coordinates to be exactly equal to y, because they have the same y coordinates, right? And the x coordinate of the first point is going to tell me exactly what the little r is. So that is blue curve. A blue curve is x equals y squared. There we go. So x equals y squared. So I'm using this, okay? Right here at the top, okay? And the red marked point, which is the very right end of the slice, is determined by the purple curve. And here we go. The purple curve is right here. X equals radical y. Okay, so then capital R is going to be equal to, radical y. Okay. So I think we're done because we have the inner and outer radii written in terms of y. So let's go ahead and write down the volume of the representative disk. So that's pi times capital R squared, capital R squared, right? So radical y squared minus little r squared. So y squared squared, okay? Times, this time we have dy, okay? So now I can go ahead and write down the volume as, oh, by the way, the y's within the region, are ranging in between 0 and 1. We talked about that earlier, okay? So y's in the green region are ranging in between 0 and 1. Let me just write that down so that this integral is going to be pi integral from 0 to 1. Okay. Radical y squared minus y squared squared dy. Okay. And what did we use here? The washer method. Okay. All right, so in this case, we wrote the integral in terms of y. In the previous case, we used the shell method and wrote the integral in terms of x. So both volumes are the same, exact same, because we're going to get the same type of three-dimensional object. Okay, so I think that's the end of it. So this is already a long video. I'm going to stop right here. And thanks for watching. I'll see you in another video. Bye.